Hello and welcome back to the course on computer vision. In today's tutorial, we're going to talk about another powerful feature of the SSD algorithm, and that is how it predicts object positions. So here we've got another lovely photo which we took in Italy, and these are just parked boats. So small boats which are parked for the day or for the night, and they're going to sometime soon go and maybe fishing or whatever they're meant to do. And as previously, we're going to overlay a grid over this image, and then for every single center of this grid, we're going to introduce a couple of rectangles, and we're going to stick with our example of 3 rectangles like that. And again, as we discussed previously, we're going to take each one of these rectangles and think of it as a separate image, and then within each rectangle, the convolutional neural network will ask the question, is there a boat or is there not a boat? Basically, it'll ask about objects. If you watch this video, this is from the promotional video for the course, and you pause it at some point, you'll see that this boat actually in one frame was recognized as an airplane, or there's like a boat and an airplane recognized in one here. So it kind of shows that it's looking for all classes of objects at the same time. So yeah, that's a good verification that sometimes if those errors happen, it just shows that maybe it can confuse an object. And this does look like a bit not like a non-standard boat because it's like a rubber boat. Yeah, so basically each one of these squares, each one of these rectangles, like let's say this rectangle, there's so many of them you can barely see. Let's say this rectangle over here is going to ask, is like just looking at it by itself, forgetting about everything else, is going to ask, is there any object inside here? Can I detect any features of an object? Yes or no? And yeah, so in our case, after the training, in the ideal scenario, these following rectangles will pick up features of boats. And so let's get rid of everything else. So there you go. You can see that these rectangles do overlap with our ground truth, and therefore it's fair to say that they will pick up certain features of boats. Again, there's a couple of things I wanted to point out here, that during training, this might not be the case. Maybe this rectangle will pick up a boat, or this rectangle, and this rectangle won't pick up a boat. But then through the iterative training process, they will learn what the features of boats are and how to pick them up and so on. So that's the training of the network. That's the lengthy, hard part. In the detection of the network, after it's trained up, this is what will happen. So we're kind of like combining the concepts of training and application. So it's important just to keep in mind what exactly we're talking about. So this is the ideal scenario of what would happen during application after the network is trained up. And so let's have a look at one specific set of these 3 boxes. For instance, this one over here. So the interesting thing is that these boxes have picked up features of a boat, right? So they can see maybe the front of the boat and this anchor line, maybe some, they can see that it's in the water. They can see like this part is a bit standing out, meaning that's where the driver stands and so on. So some of them can see more, some of them can see less, but nevertheless, none of them can see the full image of the boat. None of them can see the full ground truth of the boat. And so the question is, how can a box predict, how can like one of these temporary or inferred boxes, how can it predict where exactly the full boat will be? That's the question. So if you use your hand to just close this part of the image, how can you complete this boat without knowing where it actually is supposed to be completed? Without knowing the full ground truth, how do you know where it will be completed? And that is another special part in the SSD algorithm. It's actually not that complex when you think about it. So the underlying principle is that we have the ground truth when making these predictions, when training the algorithm. So now we're back to talking about training. So when training the SSD algorithm, we have these ground truths, we have these actual boxes, and so we can then let the algorithm make its predictions. So the algorithm, based on what it can see, based on these individual boxes, it can then make a prediction. Okay, I think the boat looks like, maybe it'll say it looks like this. So the full boat, the full rectangle should be around like this size. Although it wouldn't do that because it knows that there's no features of a boat in here, right? So, but for instance, it could say like it knows that this rectangle has features of a boat, right? So it doesn't know, maybe the boat actually goes up to the top here. So it does use the overlapping. So it makes it easier. So like if you go back, it will use the overlapping, and where they are overlapping, that's of course there's a high probability chance that there is a boat. Where the true rectangles which said yes are overlapping, there's a high probability there's a boat. But nevertheless, you can still make errors. You can still come to the assumption that the boat is higher, or longer, or wider, or something like that. But the way this is mitigated is again through training. So at the end, once it's made its predictions, there will be a certain box that it suggests for this boat. It will say that the box starts at this pixel, the bottom left corner is here, and the bottom right corner is, instead of saying here, it might say over here. And then it will actually, that result, that box that it creates, will be compared to the ground truth, and then again there'll be an error which can be calculated. And if you think of it in terms of coordinates, it can be calculated in terms of distance. There's lots of the mathematics going on in the background, so we're not going to go into that right now, how exactly the error is calculated, but you can envisage how the error could be expressed in mathematical terms, and that error would be then propagated back through the network in order to help update the weights. And again, we talked about all of this, like the backpropagation process and gradient descent, in the annex for ANN, artificial neural networks and convolutional neural networks. But conceptually, that's what is happening. So the bottom line or the takeaway from this tutorial is that through training, two things happen. The first thing is that what we discussed previously is that each box will learn to better classify objects, or better identify if it has objects inside there, and each box will use the ground truth to assess that. So, for instance, this box will say that yes, there is a boat, whereas this box, well, this box we want it to say yes, there is a boat, and this box we don't want it to say that there is a boat. And that's what will happen through training. They'll get better at that. But the second thing that will happen is they will get better at identifying the exact final output rectangle of that they should create. So we want this algorithm, the SSD, to produce this exact rectangle which matches the ground truth, rather than a larger rectangle, or rather than a shorter rectangle. So for instance, here you can see there's always going to be some sort of error. So here you can see that this rectangle, because this isn't the ground truth, right? So at the beginning we discussed that this is the ground truth. We assume this to be the ground truth, but as you can see, and at the time I said that I wouldn't draw a better rectangle around any of them except for maybe this one, but now if you look carefully, you can see that this rectangle could be a bit narrower, right? You could see that it could be a bit narrower here, and this rectangle could also be a bit narrower, so it's taking a little bit more. So there's no boat in these pixels over here on the right, there's no boat in these pixels on the left, and maybe even this one could be a tiny little bit narrower. So there we go. That's how the training happens, and so that's another element of the training that is important to keep in mind. So maybe if this algorithm was trained longer, the one that was actually applied to draw what we took as the ground, maybe if it was trained for longer, maybe this boat would have been more precisely identified during the application process. But having said that, this was quite a tough challenge, because as you can imagine, the boats are kind of like moving around, they're floating with the waves, with the little waves, and also the drone is flying. So it's actually a pretty good result for those circumstances. Anyway, so that's the second part that happens in the training. This is, as you can see, slowly we're building up the different components of the SSD. So it learns how to classify objects through the ground truth, but also uses the ground truth to identify the correct widths and heights of those boxes. And in the next tutorial, we'll continue and talk about the next component of the SSD. And I look forward to seeing you there. And until next time, enjoy computer vision.